Hey guys, today we're going to learn how to simplify and understand radical expressions. Now what we see here, this is considered a radical expression because it uses the radical symbol. Now there are a couple things to know about your radicals. First of all, what's inside of the radical, that's called the radicand. And it's basically whatever number, like I said, is inside of the radical. The next important part of a radical is this number here, if you have one. This is called the index, and it tells you what root it is that we're trying to solve for. So this is read as the cube root of 64. Now this means that you are looking for three identical numbers that would multiply to give you 64. So the number here, the index, tells you how many of the same number that you need in order to remove it from the radical. What we have seen in the past is the square root, which, as you can see, does not necessarily have a number, and that's because it's the very first radical that we ever use. So even though we don't see it, the index for this particular radical expression is 2. That means in order to remove a number from the square root, we would need 2 identical numbers. So we start off by breaking down the number. If it's 125, we have to think of 2 numbers that multiply to give you 125, which would be 5 and 25. Now the way I like to think about these radicals, and an analogy that I've used in class, is think of your radical as your house. In order to leave your house, your parents need to know that you are going out with friends, and your friends are those that are just like you. So in this particular case, we are looking for friends. We are looking for 2 identical numbers to go to the outside. 5 and 25 are not friends. They're not the same number. But if I break down 25 again, we get 5 and 5. Here are some friends. This 5 gets to go outside, but this 5 here will have to stay inside. So this radical can be rewritten as 5 square root of 5. Now this one here, the index is 4. So this is read as the 4th root of 48. So that means that I need 4 identical numbers to move outside of the radical. Or if you use the house analogy, this is a much more stricter household, and you need 4 friends in order to leave the house. So let's start breaking down 48. 48 you can think of as 12 times 4. However, I just want to note that it does not necessarily matter which 2 pairs of numbers you choose to start out with, because regardless, you're going to keep breaking them down until you find 4 identical numbers. Now this 12 can be broken down to 3 and 4. We still don't have 4 identical numbers. We have 2, but not 4. So that means that we have to keep breaking this down. Each of these 4s, however, can be broken down to 2 and 2. And then here another 2 and 2. So here we have the 4 identical numbers. This 2 gets to go outside, where the 3 will have to stay inside. So this radical can be rewritten as 2 4th root of 3. Don't forget to write down the index if it's anything other than a square root. Now over here we have the cube root of negative 54. If you ever have an odd root and a negative number inside, that just means that your answer will be negative. And the reason for that, which we discussed in a previous lesson, is that there are 3 identical numbers that are negative that can be multiplied to give you a negative. The reason why we can't have, for example, the square root of negative 4 is because we cannot get 2 identical negative numbers that would multiply to give you negative 4. That's where you would need 1 positive and 1 negative, which then are not identical. So that's why this would give us I. So to break this down, any even root, we cannot have a negative on the inside, but any odd root, you can. So let's break down this 54. 54 is 9 and 6, which 9 can be broken down to 3 and 3, and then the 6 can be broken down to 3 and 2. So we need 3 identical numbers, so these are my 3, but this 2 will have to stay inside. Now remember that this is negative, so that means that my answer will be negative, and then the 3, so negative 3 times negative 3 is positive 9, times negative 3 is negative 27, times the positive 2 will give you that negative 54. So that's what I mean by if it's negative in here, just bring the negative outside. So negative 3, and then the cube root of 2. And this would be my answer. Now let's try simplifying again, but when we have some variables. We're going to simplify all of these radicals, keeping in mind the index that's given. Remember, if no index is given, that means it's the square root, and so the index is 2. So we are looking for 2 identical numbers that would multiply to give you 32. 32 is when you multiply 8 and 4. And then the 8 can be broken down to 2 and 4. So here is my pair. So that means this 4 gets to go outside and the 2 will have to stay inside. Now let's break down this x to the 8th. If it's x to the 8th, that means that there are 8 x's. And remember that we need 2 to move it outside. So I have a pair here, here, and here. So we have 4 pairs of x's. Now we're ready to rewrite this radical. So we're going to move everything that we've circled to the outside. Since we have multiple things that we have circled, that means that when you move it outside, you multiply everything together. So this is like saying 4 times x times x times x times x, which is 4x to the 4th. Since x times itself 4 times is x to the 4th. But this 2 stays inside, so it would be the square root of 2. And this would be our answer. Let's try that again. Here we have the cube root of x to the 6th, y to the 9th. So again, this means that we have 6 x's. And this means that we have 9 y's. Because this is a cube root, that means that we need 3 identical of each term to move it outside. So we have 3 x's here and here. And we have 3 sets of y's. Since I've circled everything, that means that we no longer will have a cube root. I have 2 x's that I need to bring out, so that would be x squared, and 3 y's, so y to the 3rd. And again, there's nothing left over, so we're done with that cube root. So this will be my answer. Let's look at this next one. We have the 4th root of x to the 9th, y to the 7th. So that means that we need 4 identical of the same thing to move it outside. X to the 9th means that we have 9 x's. Y to the 7th means that we have 7 y's. So here we have a group of 4, and here we have another group of 4. That means that this x will have to stay inside. Here we have a group of 4 y's, but then these 3 don't have a 4th, so all of these 3 will have to stay inside. So when we write our answer, we have 2 groups of x's, so that's x to the 7th. We have x to the 2nd. We have 1 group of y's, so y, and then we have these here that will need to stay inside the radical. So then this would be times the 4th root of x, and then there's 3 y's, so y to the 3rd. And this would be our answer. Let's try this last one here. We have the 5th root of 64, x to the 7th, y to the 10th. So this one is a larger root, meaning that we're going to need 5 identical of each term in order to move it outside of the radical. Let's start with the 64. 64 is 8 and 8. Each 8 can be broken down to 4 and 2. And each 4 can be broken down to 2 and 2. Now we see here that we have 5 2's with this 2 that's left over. Now let's move on to x to the 7th. This means that we have 7 x's. Y to the 10th means that we have 10 y's. So we need 5. So here we have our 5 x's with 2 that are left over. And then here we have 5 y's and another set of 5 y's. So let's see how to write this answer. We have a pair of 2's, well, a group of 2's. We have a group of x's, and we have 2 groups of y's, meaning y to the 2nd. Now left over for the inside, so that means it's going to stay inside of that 5th root, is 1 2 and 2 x's, which would be x squared. And this would be our final answer. Now we're going to look at how to rewrite these radicals with exponents. Now converting a radical means that we can take that radical and convert it to an exponent that is in rational form. Rational form just means that the exponent will be like a fraction. So if you have here the nth root of a, the root is the denominator of the exponent, and the power of the variable is the numerator of the exponent. Even though we don't see an exponent here for a, that would just be 1. So if I rewrite this as an expression with an exponent, it would be a raised to the 1 over n. And if we have the nth root of a raised to the m power, then written as an exponent, it would be a of a raised to the m over n. So again, the exponent is written as a fraction where the numerator is the power and the denominator is the root. So here we have the 5th root of x, and this would just be rewritten as x raised to the 1/5. So that's how we would convert it. Now here, this is 16 raised to the 3 over 4. So I'm going to rewrite this as a radical expression, which would be the 4th root of 16 raised to the 3rd. Now you can choose to write it like this, or you can even choose to write it like this, where the entire root is raised to the 3rd power. Either way would be correct. But if we're going to simplify this, because the whole goal is to simplify, it's a lot easier to simplify the root first and then apply the exponent. So let's try that out. 16 is 4 times 4. And then each 4 can be broken down to 2 and 2. We need 4 identical numbers to move the number to the outside, and here are my 4, with nothing left over. So this can be rewritten as 2, that's the 4th root of 16, raised now to the 3rd power, which we can actually do this. 2 raised to the 3rd power is 2 times 2 times 2, which gives me 8. So 16 raised to the 3 over 4 is equivalent to 8. Let's look at simplifying some others. Here we have negative 125 raised to the 4 over 3. So I'm going to first rewrite this as a radical, and this would be the cube root of negative 125 raised to the 4th. Or you can rewrite this as the cube root of negative 125 to the 4th. Either one is correct. But for simplification purposes, it's much easier if you do the root and then you apply the exponent. Because if I apply the exponent first, like here, I will get a much larger number that may be harder to break it down. By applying the root first, we're keeping our numbers smaller. So remember here that this is an odd root, and we have a negative, so that means that my answer will be negative at the end. So let's try this out. 125 we did before is 5 and 25. And then this 25 can be broken down to 5 and 5. So here are my three identical numbers, keeping in mind that this will be negative because of this negative. There's nothing left over, so the cube root of negative 125 is negative 5, and then we're going to raise that negative 5 to the fourth power. If we raise it to an even power, our answer will end up being positive because this is four negative numbers multiplied together. Negative 5 times negative 5 is positive 25, times the third negative 5 is negative 125, and times the fourth negative 5 will give you a positive 625. So this would be our answer. Now let's rewrite this one. We have the fourth root of x to the third, y to the eighth. So what we're going to do is apply this root to everything that we see here. So this is x to the third over 4, and then y to the eighth over 4. Since remember that this is the denominator, so I just basically put both of those exponents over the denominator of 4. And now what I notice is when I do that, this x to the 3/4 won't change. I can't simplify that. But y raised to the 8 over 4, 8 divided by 4 would give you 2. So this would be our final answer, since it is as simplified as possible. Here we have the cube root of 11 to the 6th. Now if I could apply the cube root of 11, I would, but there is no identical numbers that would give us 11. So let's just convert this to a rational exponent. This is the same thing as saying 11 raised to the 6 over 3. And 6 over 3 can be simplified to 11 squared. And I can actually do this, right? 11 squared is 121. So this would be my answer. Now let's look at this one here that looks slightly more complicated. We have here 81 over 16, x squared, y to the fourth, and all of it is being raised to the 3 over 2. So I'm going to apply, remember that this is the exponent and this is the root. So this is a square root of 81 over 16, x squared, y to the fourth, and then all of that is being cubed. So now when we're applying this, what we can do here is do the square root of everything that we see. So when you're doing the square root of a fraction, this is the same thing as saying the square root of 81 over the square root of 16. And then we have the square root of x squared and the square root of y to the fourth. If you prefer to break it down like that, you most definitely can. And all of that is raised to the third power. Now the square root of 81 we know is 9. The square root of 16 is 4. The square root of x squared would just cancel, so that would be x. And then the square root of y to the fourth, this means that I have 4 y's. I need 2 to move it outside, so this would be y squared. And now what I'm going to do is apply the exponent of 3, which for the exponent we have to apply to every part of what's inside the parentheses. So I'm going to apply the exponent of 3 to the 9, to the 4, to the x, and to the y. 9 to the third power is 9 times 9, which is 81, times the third 9, which is 729, over 4 to the third is 4 times 4, which is 16, times the third 4 is 64. X to the third is x to the third, and y squared to the third, since we have an exponent raised by another exponent, we multiply those exponents together, which would give us y to the 6th. and this would be our answer. The last thing that we're going to do in this lesson is how to combine radical expressions, but we're just going to look at adding and subtracting radicals. Now, just so you understand, in order to add or subtract radicals, you can only add them or subtract them if they have the same radicand, meaning the same thing inside of the radical, or if they have the same index. So that's the one thing that you need to remember, which I have it here in blue. Both the index and the radicand must be in the same in order to combine the coefficients, because that's all we're going to do is combine these coefficients. As you can see here, we have this radical and this radical. They have the same radicand, they have the same index, so we would just add the numbers on the outside, a plus b. Here we have the same thing, same radical, same index, same radicand, so then we would subtract a minus b, just the numbers on the outside. So these are some instances when you would not be able to combine. Here we have different radicands, so the different square roots. So this would just be left like this. And then here we have different indexes. This is the square root of 3, but this is the cube root of 3. So I would not be able to combine these either. So let's look at these examples. We have here 7 square root of 5 minus 3 fourth root of 5. Here I would not be able to combine. And the reason is because they do not have the same index. Now let's look at this one. We have 3x times the square root of 2x to the third plus 4x times the square root of 2x to the third. These square roots are both identical, same index, same radicand. So what we do is we combine the numbers on the outside. This is plus, so 3x plus 4x is 7x. And then you just attach the radical. So square root of 2x to the third. So this would be my answer. Now sometimes, like in the examples we're going to look at now, it may not be so clear that we can combine them. So before we dismiss this expression as like, oh, I can't combine because they don't have the same radical, let's try simplifying the radicals first and then see if we can combine. So these are all square roots, meaning that I need 2 of each to move it to the outside. The square root of 12 can be broken down to 4 and 3. And then 4 can be broken down to 2 and 2. So this 2 gets to go outside and the 3 will stay on the inside. So this radical will be written as 2 square root of 3. Now let's look at the square root of 75. To get 75, we would multiply 25 and 3. And then 25 can be broken down as 5 and 5. So here's a pair, and this 3 will have to stay inside. So I can rewrite this radical as plus 5 square root of 3. Then this square root of 3 is as simple as we can get it, so we would just bring it down. This is minus square root of 3. Now we notice that all of these radicals are identical. So what we're going to do is combine the numbers that are on the outside. So I can combine the 2 with the plus 5, and even though we don't see a number here, this is a minus 1, because there's 1 radical 3. So 2 plus 5 is 7, minus 1 is 6, and then you attach the radical. So you kind of treat like the radical as if it was a variable. Like if this was 2x plus 5x minus x. You combine them like you would as if it was an x, but instead it's the radical 3. Let's try one more. We have the cube root of 250 plus the cube root of 54 minus the cube root of 16. So let's break down all of these radicals. 250 is when you multiply 10 and 25. The 10 can be broken down to 2 and 5, and the 25 can be broken down to 5 and 5. So because these are cube roots, that means that I need 3 identical numbers to move to the outside. And this 2 here will have to stay inside. So this will be written as 5 cube root of 2. Now let's look at the next one. We have the cube root of 54. 54 is when you multiply 9 and 6. The 9 can be broken down to 3 and 3, and the 6 can be broken down to 3 and 2. So here's my 3 identical numbers, and this 2 will have to stay inside. So this will be plus 3 cube root of 2. Last one here, we have 16. 16 can be broken down to 4 and 4. And then each 4 can be broken down to 2 and 2. So I have 3 pairs of 2's and 1 left over. So we can rewrite this radical as minus 2 cube root of 2. Now I notice that all of my radicals are identical. So we can combine only the numbers that are on the outside. 5 plus 3 is 8, minus 2 is 6, and then attach the radical, which is the cube root of 2. And this would be our final answer. Now before I close off this lesson, I just want to make sure that we all understand that it does not matter what 2 numbers you choose in order to break down the number that you're trying to simplify. For example, that cube root of 16, I didn't have to start with 4 and 4. I could have started with 8 and 2. And then this 8 will be broken down to 4 and 2. And this 4 will be broken down to 2 and 2, giving me the same answer of having 3 2's that I can move to the outside and the 1 that's left over that would have to stay on the inside. And that's simplifying radical expressions and understanding radicals.